Right, good morning to you and welcome to this third Mojo WebEx. Today we're going to be covering the security side of it, or some of the security side of it. Hopefully you can all see the screen that says Secure Physical Wi-Fi. Okay, if there are any questions at any point in time, please just say raise your hand or send it via an IM. And then I shall either answer the question at that point, if it's going to be appropriate to answer it, or I shall answer them at the end of it. Right, okay, so good morning to you. I'm Richard. I'm a pre-sales consultant at Arrow. Some of you I have met, some of you I have met on the ends of telephone calls as I've gone through the training with you as we go through. So let's start with the presentation. So securing the physical Wi-Fi. So you have wireless, but is it secure? Is it compliant? These are all questions that have to be asked or answered. So the first question is, are all of those APs on the network actually yours? Are they rogue APs? You don't know. You have to have a method of finding them out from a security perspective. Do your corporate devices try and use the guest wireless network? You may have policy that says, guest devices, they are more relaxed on their web browsing policies, etc. Corporate devices on the corporate network, we are more strict or stricter with our policy. We don't want to have a corporate device roaming onto the guest network or attempting to get onto the guest network or self-sign up, etc. on that side of it. Are your wireless networks deployed into the correct VLANs? It may be that somebody has misconfigured a switch, miscabled a switch, and we've now got the R&D secure SSID effectively bridged onto the guest network. We don't want that environment. Are your users creating personal hotspots? Why do they create personal hotspots? To share the internet connectivity, the wired side. Oh, I need to bring my, get my phone connected to the network. I've got updates, etc. What's the easiest way of me doing that? Oh, I'll make my laptop into a hotspot, and we'll then take it from there and make that device so that I can connect to it. And of course, they do it in the easiest way possible. So they'll come up with the easiest passphrases and the security. But from a security aspect, you've got an SSID that's not yours and it's on your network. So the first thing that we need to do is we need to classify the access points. Now, Mojo have a patented marker packet, which their access points, which are configured as sensors, will then send this magic marker packet out onto any VLAN that they have been either learnt about because they have an SSID that's been configured to it, or they have been explicitly told about it. We can also take an access point and actually make it into a network detector, where we actually then will monitor additional VLANs at the expense of not being able to provide any wireless service. If we use that network detector, we can have up to 100 VLANs being monitored by a single network sensor. Otherwise, we are limited to 16 if the AP is running in AP mode on most models. Basically, that's one for every SSID that it will have and an additional 4 VLANs. Now, what this magic marker packet does is it gets broadcast across the network, and if we then see that packet on the wireless side of the infrastructure, the sensor then knows that that access point is connected to one of those networks. If that is coming from an access point that we have is either part of the Mojo environment or we have authorized it to be installed on that network, we will then be able to classify that access point as a authorized access point. If we're seeing it from an access point that has not been authorized, we know that that access point must be there for a rogue access point. So we'll classify that as a rogue AP. If we don't see it, but we see just general RF coming from the access point, we know that access point is not connected to our network, so it must be an external access point. This is going round continuously, so it's monitoring the environment. If an access point, as an external access point, now gets plugged into the wired network, into our network, it would then get classified accordingly. So if it's an unapproved AP, it then becomes a rogue AP on that side of it. So we basically, as I say, we sort the good. So these are my good APs from the bad. So these are APs that should not be connected to my network, and the not mine, should I really care about them? Well, you should possibly care about them, but they're not connected directly to your network. So until they start doing something that is not desirable, so putting up your SSIDs, for example, we don't really care about them. We'll mark them as an external access point. As soon as they put up one of your SSIDs, then that is now a malicious access point, and it would then be classified as a rogue AP. We do something very similar with clients. So when the client connects to the network, based on how that client is connecting, on what SSID connecting, it may be that automatically being able to associate to the corporate SSID, which is configured to use 802.1.x against a radius, which is backed off against the corporate AD, we now have identified that that device is a corporate device because we've pushed out the necessary certificates, it's been enrolled, etc. Depends what you do, but it's an authorized device, and that's been done based on the policy that you have written on the environment. This is an approved SSID, you've connected to it. We've then connected to that. Now, it could also be that that is a guest SSID. So if it's a guest SSID, yes, it's classified, but that client is classified as a guest client at that point. If the client had first connected to the corporate network, he would then be classified as a corporate device, not a guest device. We also base it on what they're actually doing. So if we see a device plugged into our wired network, which is acting as a hotspot, internet sharing enabled, we will also classify that device. So that device would be then classified as a rogue client because he's doing something that is not normal, something we don't like doing. It can also be that rogue client is attempting to connect to a open SSID from the coffee shop, and because that device is, from a corporate perspective, it's a corporate device and he's connecting to a network that we've decided should not be desirable for a corporate device, we will then mark that client as a rogue client. We can also import a list of devices. So it may be that you say, I've got a list of the following 50 MAC addresses, 500 MAC addresses as a text document or an Excel spreadsheet. We can import them in, so they're effectively pre-known in the system. Generally, that would be done from a authorized client perspective, where you may be saying, right, I've got these X number of handheld scanners. These are all authorized to be automatically onto the environment. We don't want to see those devices then going elsewhere, so we add them to the system. You can also add them ad hoc, so as a device comes along to turn around, yes, it's been connected to the network. The policy that we've got is such that if somebody brings a BYOD device in, they connect it to the corporate network, and it then goes into a quarantine area. Can't do anything. It's got a whitelisted walled garden access, and that person then has to contact the IT department, present the device, they qualify it, yes, it's a corporate device, and then authorize it to the environment. Bit of a manual process, but it's then put onto the environment. Then at that point, it's classified as an authorized device, and then you can start to control what it's actually doing. So we're sorting, again, the good from the bad, and the somebody else's problem, which is all the external clients. So they're not connected to my network. It doesn't mean that we don't see them. It just means that we're not going to directly control them. If, however, we see that external device doing something that we don't like on our network, we can take action against it. So if it's an external device connected to the neighboring next door's SSID wireless networks, and then we see that device attempting to connect to our secured network, then we can turn around and blacklist it on our network. We won't blacklist it on the external network, but we will blacklist it onto our network. One of the other things that needs to be taken into account is the SSID configured correctly? Generally, networking and security sit under different people's responsibility. So the security people will say, this is the policy, this is the requirements, we need to have WPA2, it needs to be configured on these particular networks, these are the settings, we want to be using 802.1.x, etc. The wireless guy then configures. What happens if the wireless guy misconfigures, or somebody comes along later on and, oh, we're having problems connecting, oh, let's just try this setting onto the wireless setting that makes the devices connect more easily. Those devices are now connected. However, from a security perspective, you have not met your security requirements. And the only way the security officer would know this would be to either continually validate the configuration settings, or they're not aware of it. Is the SSID deployed at the correct location? It may be something silly like you've got a secure R&D network, and the last thing you want to do is have a public guest wireless network being deployed there because your policy says it mustn't be deployed at that point. You don't know about it unless you're physically looking down at that area. Deployed onto the correct VLAN on the network or VLAN. The wireless guy has configured it to use VLAN 5. Somebody in the switching infrastructure has misconfigured a switch, so instead of putting the native VLAN to be port 5, they put something else. We don't know. It's not in the wireless guy's hands. Is wireless allowed? It may be that wireless is not allowed in that environment. There are some people that will deploy a wireless solution, what appears to be a wireless solution purely to block all wireless activity. There should be no wireless SSIDs being broadcast in our R&D environment. Everything is wired. There is no requirement for it. How can we validate that nobody has got a laptop which they decided to make into a hotspot, or somebody comes along with a access point from somewhere, plugs it into the network, so we have a local environment? That's the sort of thing that we can now validate and confirm on this side of it and take the necessary action. So if the SSID is misconfigured, we can flag it up and potentially stop clients connecting to it. If it's deployed at the correct location, if it's not deployed at the correct location, we can stop clients connecting to it. Is it deployed onto the correct VLAN? Well, again, we can then stop clients connecting to that SSID. Even if the access point is not effectively directly controlled from the Mojo environment, we can be starting to send either or disassociation packets to any client that connects wirelessly, and at the same time we can do gratuitous ARP requests to actually poison any wired client activity, or more importantly, even if that wireless client did manage to get connectivity, from a networking perspective, all of their traffic is going to be sent to the sensor access points, so they're not actually going to have anything being conducted around the environment. So we are effectively putting a ring fence around that client and either stopping him having anybody connecting to him, or having anybody any traffic coming from that client being controlled. So we want to start to protect your environment. So clients causing problems, and these clients could be, authorized devices connecting to guest SSIDs or external access points. So this is the corporate device that is in the shared office environment, and he's now attempting to connect to the coffee shop SSID downstairs because it's an open SSID, and he can then do what he wants to do. From a security perspective, we don't want that happening. We've got clients, as I said, that are bridging or connection sharing. Again, we don't want that happening. We've got ad hoc networks. So this, somebody says, oh, I've just quickly set up an ad hoc network so I can get out copy files, etc. Doesn't really belong into the enterprise, the ad hoc network. Biggest problem is, of course, wireless printers. Wireless printers are, generally designed for domestic environments where the ad hoc network is very much a requirement. So they will, in comes the printer. Yes, it's an ad hoc network, but it's also wired to the network. Our security now is the restriction of that printer. So, how do we stop people using it? It could be something as simple as, somebody can connect to a well-known ad hoc network and they can be printing, but this is next door. We don't want people connecting to it. We can control all of that. That's from the client side. And of course, we also have access points that can be misbehaving in some form or another. A rogue AP, so an AP that's not supposed to be plugged into my network, and it is. I want to control. I want to stop clients using it. So I can be automatically saying, no, nobody should be connecting to that. So anybody does connect, we will send disassociation packets to it. We'll also turn around and poison all the ARP tables so that that traffic comes to me, doesn't go to the access point. We can have the evil twin, so somebody acting as a honeypot, trying to coax your users to connect to their version of your network. Obviously, if you're using the more secured methods being deployed in the correct manner, so 802.1.x deployed, client configured correctly, the client will pick up that is not the legitimate server client or the access point, and will refuse to connect. However, if you're not using that security, or it may be that you're putting up your own WPA pre-shared key and you're trying to connect to it, we don't want that to happen. A misconfigured AP, so it's one of your APs, but the SSID, somebody's turned the security settings down on it. The SSID is being broadcast, but it's being broadcast in an area where it shouldn't be broadcast. They are all misconfigured. So we will stop clients and say connecting to the misconfigured part of the environment, not the correctly configured part. So the guest SSID should not be down at R&D. So we'll stop the guest SSID working down in R&D, but we won't stop the corporate part working. We have banned APs, so the reverse of an approved AP. So this AP has been banned from our network. We've told him he shouldn't have it plugged into it. We've manually marked it as a banned device. It's sitting next door, different networks. We don't want our clients connecting to it. We want no clients connecting to it, so we'll ban it. How do we know it's connected to our network? We don't 100% know. However, it may be from a physical perspective. We know that we are in an environment where there is no possibility that a third party's RF perspective would be encroaching into our environment. Think of an office block or an office in a large grounds, no immediate neighbors, and an access point pops up. It's not connected to our network, but it shouldn't be there. So we will ban that access point because, how's it there? It shouldn't be in the environment. We have the WPA2 or the WPA crack. It's not necessarily just security from your clients. It can also be security from your existing infrastructure. Other vulnerabilities from protocol perspective or standards. This is a nice true Mojo slide here where we have the WPA crack from October last year. it was released and notified to the public, this is going to be a problem, 2 o'clock on the 16th of October. Most manufacturers, some of them haven't still fixed the problem. Some of them are saying, fix it by doing this, turn off the .r. It doesn't really fix it because there's still some client side. Well, from Mojo, hang on. From Mojo, we had it fixed at 4 a.m. So 2 hours later, they had the AP side and the full client mitigation configured. Well, as they say, it wasn't really a fix because it was always in the solution, and it was in the solution because we have that third radio, and that third radio can actually see what's going on. So the full AP whips can block any AP MAC spoofing on any WLAN AP that it protects, and this is the third radio coming into effect on that side of it. So 2 hours after the vulnerability was reported and publicized, it had been fixed or had been addressed. We can enable client isolation, one tick box, and it's done. And it was fixed, I would say, in this emergency 8.5 release that was released very shortly after the environment. We also have, guest users. So what are you doing with your guest users? These are devices that are not connected to your environment. We have some requirement to, control what they're doing. If we're a relatively small customer, small site, we may not have gateway URL filtering that we can implement. We can implement, however, content filtering actually on the SSID. Currently, you can only easily set it up using the Nano interface. However, that will be coming across into the Aware interface in the short future. Nice simple pull down box. Various options. You can say all the security stuff, so spyware, malware sites, hacking sites, pornography, and then the other is the hacking sites. Not necessarily a security issue, but giving people the information as to how to do it. It's a pull down box. You've got a choice of 3, or you can specify your own external. Now that is included, in the environment, designed for I'm going to say the smaller type of deployment where you haven't got the additional gateway filtering, but you could use it in there on that side of it. We also have self-service, so the user, when they hit the portal, they hit a web portal, they have to provide some information. Now that information may be just a name, so give us a name and an email address and we'll send you a code. That doesn't really validate. It may be totally open. We can also turn around and take that one step further and say we'll give you paid access. So by creating a payment gateway with Swipe, we then pass the credit card details to them, validate, they then buy the service. So you can have that tiered service. You can give them half an hour of free access, 15 minutes of free access, then move on to a charged process on that side of it. You're collecting that information. We could take it almost another step further, and we can then do a sponsored access. So sponsored access is very useful in the enterprise environment. Little bit of configuration, you connect to the guest SSID and you get directed to a web page. You have to give some information. We need an email address from you, and we also need your host's email address. Now we can tie down to say the email host is anybody at your particular domain or domains, or individual people at those domains. So a very easy, simple way of when an official visitor comes to an organization, yes, I need internet access. Well, instead of having to trot down to reception to get them a wireless key, talk to IT, etc. Okay, not a problem. Hit the SSID, give me your, put my email address down on a corporate device. Yes, I click the email. Yes, I received that. Yes, I'm going to give that person access. Of course, it's all recorded so that we got the history, who's actually validated this, who accepted it, who gave the permission for them to connect. and away they get connected to the environment. So another way we can have that secured access to the guest network and take some of the overhead from receptionists, IT away from the environment. It's all very well having this nice secure environment solution. However, generally people say we want to have this reported on. How do we know that this is actually secure? Certainly, if you're doing anything with credit cards and things like that, you're going to need the PCI requirements. Is your wireless network secure? Well, you have methods. You can go through all of the configuration. You can validate it, and it's valid at that point in time. And then it needs to be revalidated. Well, with Mojo, they have built-in compliance reporting. There's a load of custom predefined reports out of the box. All the main ones are there. You can create your own custom ones. And the nice thing is that you can click the, generate a report over this time frame or on this particular date, and it will then analyze the recorded information that we've received from the environment and put it into a nice report for you. It can even be scheduled, so it's emailed to you based on yesterday's information every 8:30 in the morning. So we have a compliant report all the time. Do we have any questions from anybody? I've not seen anything pop up. No questions? Okay, so it's now over to the competition time. We have a running competition at the moment where if you attend a webinar, so you've attended a webinar, we will send you a Mojo t-shirt. If you post a social media of you wearing that t-shirt with the hashtag of where is your Mojo, you can be entered into this draw for the England-Wales Six Nations Rugby with full hospitality, and there's some other spot prizes on that side of it. Please make sure that you send an email to mojo.ecs.uk@arrow.com with your address and size requirement for your t-shirt on that side of it. We also have another incentive where some of you may have already been aware that everything in Mojo is generated by APIs or controlled by APIs, and it is possible to tie into that with Alexa the method of testing environments. So, as it says here, if you embrace that technology, we will give you, an Amazon Echo Dot with every closed deal. Need to be qualified, so it must include those 20 of the Mojo access points. I would just like to thank you all for attending.